Hello everyone. Let's just introduce ourselves because this is the first class. So, I will start with myself. My name is Asma Parveen. I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So, now I request all of you to please unmute yourself and introduce yourself. So, can we start with Nilesh Rokadeji?
Yes, ma'am.
Sure. Please introduce yourself.
Am I audible, madam?
Hello.
Am I audible, madam?
Yes, you are audible. So I think he is having some issues. So can we go to Sadarshan Veeraji? Okay, I think he is not available. So Jasmine Lad, can you just unmute yourself and I'm so sorry my mic was off. Jasmine Lad, can you just unmute yourself and give a brief introduction about yourself?
Good afternoon, ma'am. I'm Jasmine Lad from Gujarat.
Good
I've
afternoon.
done my master's in environmental engineering and I want to learn about environmental chemistry, so I have joined this course.
Okay, so
Thank you, ma'am.
okay, you are a PG student?
No, I'm currently on maternity leave.
Okay. Okay, thank you. So Balaji Rajamani, can you just introduce yourself?
Hello.
Hello.
Good afternoon, madam.
Good afternoon, sir.
Yeah, I am Balaji. I have completed my BTech in chemical engineering, and I am working in desalination and wastewater treatment as process engineer.
Okay. Okay, thank you so much.
Thank you, madam.
Jenny, can you just unmute yourself and introduce yourself?
Good afternoon, madam. My name is D. Vedas.
Hello, ma'am.
Yeah.
Good afternoon.
Good afternoon.
Yeah, I'm Jennifer. I'm from Tamil Nadu. I'm a postgraduate chemistry graduate. Yeah, I'm hearing to know about environmental chemistry and explore more certification courses since I have enrolled this course.
Okay. Thank you.
Thank you.
Yes, Sudarshan Viraji. Okay, we'll move forward. Gayatri Ramalingam, can you just unmute yourself and give a brief introduction about yourself?
My name is D. Vedas Darshan, madam.
Okay.
I am working as a lecturer in chemistry, Government Degree College, Jammu, Andhra Pradesh. I am doing my PhD in part time, JNT University, Anantapur, Andhra Pradesh.
Okay, thank you. So Gayatri and Madhvi, can you just unmute yourself one by one and give a brief introduction about yourself?
Yeah, good afternoon, madam.
Good afternoon.
This is Madhavi from
Ma'am,
Madhya
I
Pradesh.
am Gayatri Ramalingam. I am from Tamil Nadu working as a professor in Power Engineering College. I am from chemistry department. I like to know what is the difference between environmental chemistry in engineering and civil. So only I entered in this subject now.
Okay. Okay, thank you.
Thank you, ma'am. Thank you.
Now, Madhvi, you can introduce yourself.
Yes, ma'am.
Hi.
This is Madhavi from Andhra Pradesh. I'm working as a lecturer in chemistry in technical education. In our curriculum, we have the environmental studies. So better to know the advanced processes happens in the environmental studies. For that purpose, I joined in this course.
Okay. Thank you.
Thank you, ma'am.
So one is left, and Davi, can you just please introduce yourself? Okay, I think she is not available. So so basically, this is the problem solving session. My schedule is on Sunday from 3 to 5 p.m. So we will discuss the previous year questions of the subject. So someone has raised a hand. Gayatri Ramalingam. So Gayatri Ramalingam has raised her hand. So is there any question or query? So can anyone confirm if I'm audible or not?
Yes,
Audible.
madam, you are audible.
Okay. So please don't call me ma'am or madam. I'm just a PhD scholar, so you can call me by my name. So good afternoon and welcome to the first online problem solving session of the course Environmental Chemistry. The instructor is Professor Bhanu Prakash Valenki from the Department of Civil Engineering, IIT Roorkee. I am one of the TA for this course. As I have introduced myself, I am a PhD scholar at IIT Kanpur. So my session is from 3 to 5 p.m. on every Sunday. There is one more session by another scholar. She will be taking the on Tuesday. I am not confirm about the timing. So her session will be on Tuesday and mine will be on Sunday. So what I have done is like we are told to solve the previous year questions. So I have taken the question from this course of the previous year and I have added some additional questions from the reference book which was mentioned by the professor. We will try to solve the questions and if you have any doubt you can ask me. So I have not added the summary of what was taught in the week 1. If you all want this, then I can add from the next week. Like we can go through what was taught in the previous week for about 15 to 20 minutes and then we can follow with the questions. But this week I have started with the question. So can we start?
Yeah, ma'am.
Okay. So what we'll do, I will give you a question and I will give you 2 minutes so that you can solve the question, or if it is a conceptual based then you can find out which one is the correct option, and you can just write the correct option in the chat box. So the first question is very straightforward. It is molarity is defined as mole per unit volume, concentration per unit volume, equivalent weight per unit volume, or mass per unit volume. So I'll give you 2 minutes, just take your time, and just everyone please write your answers in the chat box. So yes, the option A is correct. Molarity is defined as moles per unit volume. So we'll move to next question. So the question is value of gas constant. We have to find out which one is the correct option, A, B, C, or D. Please write your answers in the chat box. All of you have written B, but B is not the correct option because we have to see also the unit for R. So I'll give you 1 more minute to just think which one is the correct, and then we will proceed. So the correct option is A, 0.08206, that is 0.0821 liter atm per mole per Kelvin. For the B option that is 8.314, the unit is different for this. For this, the unit is joule per mole per Kelvin. So why deciding the value of R, we have to be very much conscious about what units to be used, because the value of R changes with whatever unit is mentioned in the question. So there was one raised hand by Sudarshan Veera. So do you have any doubt?
No, madam. Initially, I thought that 8.314, later on units are different. That's why I shifted my answer to first one.
Okay. Okay, so I'll move to next question. So next is a numerical based question. So the question is, the molarity of 99% concentrated H2SO4 having density equal to 1.82 grams per ml is. So we have to find the normality of the given H2SO4 solution. So I'll give you 3 or 4 minutes to solve this question and just write your option in the chat box. So I got 4 options as B. So the correct answer is B. So we'll see how to solve this. So we have been given is that 99% H2 SO4 solution. This means that 100 gram of the solution contains 99 gram of H2SO4, and we have been given the density as 1.82 grams per ml, which means that 1.82 gram H2SO4 solution will have volume of 1 ml. So we'll find out the volume of 100 gram of the solution. That will be 1 by 1.82 into 100. This much ml is the volume of the solution. Now we will find out what is the molecular mass of H2SO4. So for molecular mass, we have 2 moles of hydrogen. So 2 into atomic mass of hydrogen is 1, plus we have 1 mole of sulfur, and atomic mass of sulfur is 32, and we have 4 moles of oxygen, and atomic mass of oxygen is 16, and the molar mass of H2SO4 will be 98 grams per ml. So after solving this, 100 gram of H2SO4 solution will give us, so no need to solve this, we can solve it at the end. So now we have to find out normality. So normality is number of equivalents per liter of the solution, that is volume of solution, and number of equivalents is given as given weight of the solute to equivalent weight into volume of the solution. So here we are given that 99% of H2SO4, that is in 100 gram of the solution we have 99 grams of H2SO4, and for equivalent weight is calculated as molecular weight or atomic weight upon Z, where Z can be charge on the atom or molecule, or it can be number of H plus or OH minus ions given by that molecule, or it can be number of electrons transferred during a oxidation reduction reaction. So here we are given H2SO4. So H2SO4 will give us 2H plus and SO4 2 minus. So here Z will be 2. So equivalent weight will be, molecular weight is 98 upon 2. So here we will put the values. Equivalent weight is 98 upon 2 into, we have the volume of solution as 100 upon 1.82, and since this is in ml and everything else is in grams, so for converting it into liter we will divide it by 1000 and we will get the appropriate value. So after solving we are getting the value as 36.77 N, that is normal. So if anyone have any doubt, then please ask me, or if anyone have, so someone has written in the chat is that equivalent weight is molecular weight by N. Yes, it is right. So anyone have any doubt in this question? Okay, then we'll move forward to the next question. Sorry. I think I have to rub it. So the next question is, acid are defined as the one which donates hydroxide ions, donates electrons, or donates proton, or D, which is A and C, that is donates hydroxide ions as well as donates proton. So I'll give you 2 minutes, just take your time and write the correct option. So the correct option is C, is that acid are those which donates proton. So there are some answers which says that option D is the correct option, but it is not, because Lewis acid accept electron pair from another compound. Like here is an example given, like H2O plus H plus gives H3O plus. So here H plus is accepting proton electron pair and forming a complex H3O plus. So H plus is here is the Lewis acid. So we'll move to the next question. Oxidation is defined as, choose all the correct options. We have there are multiple options which are correct. So A option is gain of electrons, loss of electrons, loss of hydrogen, or D, gain of oxygen. So I'll give you 2 minutes, just take your time and write your option in the chat box. So the correct options are B, C and D. Gain of electron is reduction, loss of electron, loss of hydrogen, and gain of oxygen is oxidation. So we'll move further. So here is a question. Convert the given concentrations to equivalent units respectively. Calcium, we have given the mass concentration of calcium sulfate, magnesium sulfate and calcium carbonate, and we have been given the atomic weight of the elements, and we have to find the equivalent units. So I'll give you 4 minutes. Please take your time and solve the question. So someone is asking, Jenny is asking, what is actually equivalent weight? Actually we have to find equivalent, here we have to find out the equivalent units, which is equivalent to number of equivalents. We have to find out here the number of equivalents of each compound. So I just got one answer as B, but B is not the correct option. So I'll give you all 2 minutes more. Please try to solve this question. And equivalent units is that we have to find out the number of equivalents in this question. So I got one answer is C. So C is the correct option. So we'll see how to solve this. So here we are given 136 milligrams per liter of calcium sulfate. So first we'll find out what is the molecular weight of calcium sulfate. We have 1 mole of calcium, so 40 into 1 plus 1 mole of sulfur, 1 into 32, that is 32, plus we have 4 moles of oxygen, so 16 into 4, that will be 136 milligrams per liter. Now equivalent unit or number of equivalents is equal to the given weight to the equivalent weight, and in the previous question we have seen that equivalent weight is molecular weight to Z, where Z can be charge on the molecule or atom, or it can be I don't know, is this Z is the charge, or it can be number of H plus or OH minus donated by the acid or base, or it can be number of electrons transferred during a oxidation reduction reaction. So here we have calcium sulfate. So calcium sulfate will give Ca2 plus and SO4 2 minus. So here Z will be 2. So equivalent unit will be given weight, that is the molecular mass will be grams per liter. So here the equivalent weight of calcium sulfate would be, given weight is 136. I don't know why it's not working. So it will be so the pen is not working. Just give me 2 minutes. So here the given weight is 136 milligrams per liter. We can do like this, we can multiply by 10 power minus 3, and equivalent weight would be 136 upon 2. So after solving we will get 2 into 10 to the power minus 3 equivalents, or 2 milli equivalents. So similarly, for magnesium sulfate, we'll find out the molecular weight. That would be 24 plus 32 plus 16 into 4. That is equals to 120 grams per mole, and equivalent units would be, so MgSO4 has magnesium as +2 charge and sulfate has -2. So it would be, given weight is 240 milligrams per liter divided by 120 grams per mole upon 2, that is 4 milli equivalents. And last is calcium carbonate. So molecular weight would be 40 plus 12 plus 16 into 3. So it would be 100 grams per mole, and equivalent unit would be, given weight here is 400 upon 100 upon 2, because calcium carbonate, calcium is +2, that would be 8. So we have 2 milliequivalents of magnesium sulfate, calcium sulfate milliequivalent is 2, magnesium sulfate is 4 and calcium carbonate is 8. So the correct option is C is the correct option. So there is some problem. I'm sorry for the disturbance. This is the first class, I guess that's why. Don't know why. So we'll solve the next question. That is, convert the given concentration to molar units respectively: calcium sulfate, magnesium sulfate, calcium carbonate. So this is the extension for the previous question. We have to find out the molar units, that is millimolar, number of moles per unit volume. So I'll give you 4 minutes. Please solve this question and write your answer in the chat box. No, C is not the correct option. So the correct option is D. So we'll see how to solve this question. So molarity is, we have to find the molar units, that is molarity. It is molar units, or molarity is number of moles per liter of the solution, that is volume of the solution. So for calcium sulfate, we have already calculated the molecular mass, 136 grams per mole. So its molar unit will be, given weight is 136 milligrams. We'll divide it by 1000. It is grams per liter divided by molecular weight 136 grams per mole. So it is 1 into 10 to the power minus 3 mole per liter, which is 1 millimolar, or we can write as 1 small m for milli and capital M for molar. Similarly, for magnesium sulfate, we have the given weight as 240 and its molecular weight is 120. So it will be 2 millimolar. And for calcium carbonate, we have been given 400 milligrams per liter and the molecular weight is 100 grams per mole. So that will be equivalent to 4 millimolar. So correct option is 1, 2 and 4. So correct option is D. So we will move to next question. So the third question is, select the correct option. A, all steady state processes are at equilibrium. B, all equilibrium processes are at steady state. Equilibrium is defined for only closed systems. Or D, steady state is defined for closed system. So it is a straight question from what was taught in the lecture by the professor. So I'll give you 2 minutes. Please write your answers in the chat box. So only one option is correct. So please go through this question once again and just write the correct option. So C is the correct option, is that equilibrium is defined for only closed systems. So we'll move to the next question. It is a numerical based question. Benzene is dissolved in water to form a solution of 1 liter with a concentration of 55.6 moles per liter. The initial concentration of benzene in pure organic liquid form is 800 milligrams per liter. Calculate mole fraction for benzene in the given solution. So it is a very straightforward question. We have been given the total number of moles and we have been given the weight of the benzene. We have to find out the mole fraction for the benzene. So I'll give you 4 minutes to please solve the question. Please solve the questions and please participate while solving the questions, because I am getting only 1 or 2 answers for each question. So I request everyone to please solve the question and write your answers in the chat box. So I'm sorry for the disturbance. There was some network issue from my side. So we'll see. Okay, I got one answer. That is A. So A is the correct answer. So we'll see how to solve this question. So we have given benzene. So benzene is C6H6. We'll find out what is the molecular weight. 6 moles of carbon, so 6 into 12, and hydrogen is also 6, so it is 78 grams per mole. So the number of moles will be, we have 800 milligram per liter of benzene, so 800 into 10 to the power minus 3 upon 78. This is the number of moles, and mole fraction is given as number of moles of solute, of that particular solute, divided by total number of moles. So we have been given that the overall number of moles in the solution is 55.6. So total number of moles is 55.6, and number of moles of benzene is 800 into 10 to the power minus 3 upon 78. That is equals to 1.845 into 10 to the power minus 4. So correct option is A. So if anyone have any doubt, then you can ask me. Otherwise we can move to the next question. Okay, we'll move to the next question. So the next question is calculate the delta G naught for the reaction. So we have given a reaction and we have given the delta G naught for the formation of the compound. So it is a state question. We just have to find out what is the delta G naught for the reaction. So I'll give you 3 minutes. Please solve the question and write the correct option in the chat box. will see how to solve this question. We have to find out the Gibbs free energy for the reaction. So the Gibbs free energy for the reaction is given as summation of Gibbs free energy of product minus summation of Gibbs free energy for the components in reactant. So we have one compound in the product, that is Fe2O3, and the Gibbs free energy of formation of Fe2O3 is minus 742.7 kilojoules per mole, and in the reactant, we have to multiply here with N also. N is the stoichiometric coefficient of each of the compound involved in the reaction. So we have 2 moles of Fe2O, so that will be 2 into delta G naught of formation of FeO is minus 251.1 plus we have O2, delta G naught of formation of O2 is 0, so 1 by 2 half into 0. So after solving this, we are getting the value as minus 240.5 kilojoules per mole. So the correct option is C. So we will move to the next question. So this is also a numerical. We have to comment on the feasibility of the given reaction. The reaction is given and we have been given the activities of each of the compound involved in the reaction, and also the equilibrium constant is given. We have to find out if the reaction is feasible, not feasible, at equilibrium, or products are converted to reactant, that is if the reaction is going in the reverse, that is from the product side it is going to the reactant side. So I'll give you 3 minutes to solve this question. Please solve the question and write your options in the chat box. will see how to solve this question. We have been given the equilibrium constant. So for any other condition except equilibrium, we will find out what is the reaction quotient, that is Q, which is ratio of activities of compounds in the product to the activities of the reactants. So we have been given activity of H3O plus is 10 to the power minus 7, activity of OCl minus is 10 to the power minus 4, and activity of HOCl is 10 to the power minus 3, and activity of H2O is 1. So we'll find out Q is 10 to the power minus 8, and here we can see that Q is less than K. So this reaction will have the tendency to move in the forward direction from the reactant to the product side. So the reaction is feasible. So correct option is A. So we'll move to the next question, is select the correct option. Del G is state variable, B is del H is, that is enthalpy is inversely proportional to del G, or entropy is directly proportional to del G, or I should say change in entropy is directly proportional to del G. Or D, if the number of moles of product is more than reactant, degree of disorder decreases. So there is only one correct option. We have to find out which one is the correct. So I'll give you all 2 minutes, just find out and write your answer in the chat box. So we'll see which is the correct option. So A is the correct option. We have, so sorry, we have the relation del G equals to del H minus T del S. So with increase in enthalpy, there will be increase in del G. So here it is directly proportional. And for del S, if del S will increase, so this value will increase and del G will decrease. So there is So it is inversely proportional to del S. So B and C are not the correct option. And if we see, with increase in number of products, degree of disorder increases. So only del G is state variable because it depends upon the condition, but del G naught is fixed for, because it is given at the standard condition of 25 degrees centigrade and 1 bar pressure. But del G is state variable because it depends upon what are the conditions during the reaction. So we'll move to the next question. So this is also numerical. Analysis of the water gave concentration of Na plus, Ca2 plus, chloride and bicarbonate of 9, 21, 6 and 45 milligrams per liter respectively. Calculate the ionic strength of the water sample. We have been given the molecular weight for each of the elements, and we have to find out the ionic strength, and the formula is also given for ionic strength. Ionic strength is 0.5, that is 1 by 2 summation of Mi into Zi square, where Mi is the molarity of component and Z is the charge. And for dilute system, we take molality as molarity. So here we will also find out the molarity of each of the component, and we will find out the ionic strength. So I will give you all 3 minutes. Please solve the question and write your option in the chat box. So we will see how to solve this question. So for each component, so the ionic strength will be half, and we will write the Mi square for each component. For sodium, Mi would be, given weight is 23 upon, given weight is 9, given weight is 9 and molecular weight is 23 into the charge for sodium is 1, so 1 square, plus we'll write it for calcium. The given weight of calcium is 21 and molecular weight is 40 into the charge for calcium is 2, so it would be plus 2 into plus 2 ka square 2, plus for chloride the given weight is 6 upon molecular weight is 35.45 and the charge for chlorine is -1, so whole square of -1, plus bicarbonate, we have 45 milligrams per liter of bicarbonate, and molar mass of bicarbonate would be, we will calculate the mass of bicarbonate, that would be 1 plus 12 plus 3 into 16, that is 61 grams per mole. So it would be 61. So we'll solve this and we will get the value of 1.6991 into 10 raised to the power of -3, because all these values are in milligrams and molar mass is in grams, so we will divide it by 1000. So we have the ionic strength as 1.7 into 10 raised to the power of 3. So the correct option is B. So we'll move to the next question. So the question is, select the incorrect option. A is Henry's law is applicable to dilute liquid gas interaction. Rawls law applies to non-dilute solid liquid interaction. Or C, for hydrophilic compounds KOW value is lower and for hydrophobic compounds KOW is higher. So I'll give you all 1 minute to solve this question. It is a conceptual question, so just write your answer in the chat box. So B is the incorrect option. Rawls law is applicable to non-dilute gas liquid interaction. So Henry's law is the amount of gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid. So Henry's law is given as activity in the gas phase to the activity in the liquid phase. So after solving this, we will get if the system is dilute, then in place of activity we will take the concentration. So it would be Kh into C. C is the concentration in water and Pg is the partial pressure in the gaseous phase. And for Raoult's law, the partial vapor pressure of the solvent in a solution, that is a solution is mixture of one or two or more solvent, it is given as the mole fraction of the solvent into vapor pressure of that solvent into the pure form. So we'll move to the next question. So it is a numerical based question. It is a very simple question, only there is lot of information given for the question. So the question says the normal amount of energy available in methagenic processes forces the microorganisms involved in very efficient cooperation. In many cases, neither partner can operate without the other, that is, together they can exhibit a metabolic activity that neither one could accomplish on its own. Such cooperations are called syntropic relationship. A typical example is the Methanobacillus melansky culture, which is a co-culture of two partner organisms, strain S and strain MOH. The two strains cooperate in the conversion of ethanol to acetate and methane by interspecies hydrogen transfer as follows. So till now it is just a brief introduction about the strain S and strain MOH, how they form symbiotic relationship with each other. So the main instruction for the question is given in the next para, that is the critical point in this syntropic cooperation is that the reaction that strain S is catalyzing is only exergonic if the hydrogen partial pressure in the aqueous phase is low enough. Hence strain MOH must move hydrogen efficiently from the solution. So for the strain S to form acetate, H2 should be removed from the solution by strain MOH, then only these two reactions will complete. And we have to find out the maximum partial pressure at which the strain S can just gain some energy from catalyzing reaction 1 at pH 7 and 25 degrees centigrade by assuming that both ethanol and acetate are present at a concentration of 10 raised to the power minus 6 molars. So in this question we have to find out the partial pressure of hydrogen for the reaction 1, and we have been given the concentration of ethanol and acetate. But to solve this question we would need the Gibbs free energy for the components involved in reaction 1. So I'll give you the Gibbs free energy. So for ethanol, the Gibbs free energy of formation is minus 181.8 kilojoules per mole. For acetate, For acetate it is minus 369.4 kilojoules, and for water it is minus 237.2 kilojoules, and for hydrogen gas and H plus it is 0. So we have to find out the maximum partial pressure at which the strain S can get some energy from the reaction 1. So I will give you all 5 minutes to solve this question, and then we will see how to solve this question. So whoever is getting the answer, please write your answer in the chat box. So I have not received any reply for this question. So we'll see how to solve this question. So it is based on del G. So we have to find out the maximum partial pressure at which the strain S can just gain some energy, and from the previous information we get to know that the first reaction cannot proceed if there is accumulation of hydrogen gas. So at equilibrium there will be the maximum accumulation, that will be the maximum partial pressure above which the reaction 1 cannot proceed, and if the partial pressure is below that partial pressure of the hydrogen, then reaction 1 can proceed from left to right, that from the reactant side to the product side. So we will first find out what is the del G for this reaction. So del G naught would be N into summation of del G naught of formation of the product minus number of stoichiometric coefficient for each compound into summation of so del G naught for the reaction would be summation of N into delta G naught of formation for the product minus summation of delta G naught of formation for the reactant, and here N is the stoichiometric coefficient for any compound involved in the reaction. So here we have the reaction of so here we have the reaction of CH3 CH3 CH2OH aqueous plus H2O, that would be aqueous. This is giving us acetate CH3COO minus aqueous plus H plus aqueous plus 2H2 gas. So we will find out what is the delta G naught for the reaction. So for acetate we have the value of minus 369.4. For H plus and H2 it is 0. Minus for the reactant we have ethanol. So delta G naught of formation for ethanol is 181.8 kilojoules per mole, and for water it is 237.2 kilojoules per mole. So after solving this we are getting 49.6 kilojoule per mole, and we can see the delta G naught for the reaction is positive, so this is not a feasible reaction. So at equilibrium we have delta G for the reaction is delta G naught plus RT ln K. So we have to find out the maximum partial pressure. So at maximum partial pressure the reaction would be at equilibrium, so delta GR for the reaction would be 0. So this implies that we have minus delta G naught of the reaction is equals to RT ln K. So we have minus 49.6 This is in kilojoules per mole, so we have to be very cautious while putting the value of R. That would be 1.314 joules per mole per Kelvin. Since it is in joule, so we will divide it by 1000. Temperature is 25 degrees centigrade, so it would be 298 Kelvin. We have to put this in Kelvin. And log K, so that would be activities of product to the ratio of activities of product to the reactant, and the system is dilute because nothing is mentioned about activity or product, so we will take the system as dilute. So instead of activity we will take the concentration. I think I should move to the next page. So we have delta Rg is delta R gr naught plus RT ln K. This is 0 at equilibrium, so 49.6 is 8.314 into 10 power minus 3 into 298 log. So we have acetate and we have H plus so we will solve this. We have been given that concentration of CH3CO minus and CH3CH2OH is equal, that is 10 power minus 6, so it will get cancelled. And we have pH as 7, so pH is nothing but minus log activity of H plus, since we are taking the system as dilute, so it would be concentration of H plus since pH is 7. So concentration of H plus would be 10 raised to the power minus 7, and partial pressure of hydrogen raised to the power 2, since the stoichiometric coefficient for hydrogen is 2 there, and activity of H2O is 1, so it would be 1. So after solving this we will get the, so I will solve one more step, minus 49.6 ln this, and we are getting pH2 whole square as 0.0202, and after solving this we are getting the partial pressure of hydrogen as 0.1421 bar. So the correct option is C. So I hope this question is clear to everyone. So if anyone have any doubt in this question, then please ask, otherwise the time is over. So I think no one have any doubts, so thank you so much for joining. But I have one question, like should I just start with the previous year questions, or I should give a brief recap of what was taught in the previous week lecture? So can anyone just unmute herself or himself and give suggestion? Okay. So I got one reply, week lecture ma'am. So from next week onwards, what I will do, I will give a 15 to 20 minutes recap for what was taught in the lectures, and then we will move to the questions. So thank you so much for joining, and please do join next week on Sunday from 3 p.m. So have a nice day. Thank you.
Thank you.
Thank you.